Okay, we should be live. We've got some stuff to do today. Gotten some rest over the weekend and had some time to think about Puffer. I've been making a ton of progress lately on the environment side with Puffer. Um, but there's this thing that's been bothering me with the infrastructure. It's gotten too complicated and a little clunky. I think I found a way to fix that. So the goal for the next few hours here is to do that end to end, get it working, and ship it to dev branch. It's a lot of stuff to do, but I think it shouldn't be too bad. Mainly, I figured out the way that I want to deal with all the data storage for this stuff. I think it's going to be simpler than the way I have it now. It requires one additional API call. It saves subclassing. You don't have to subclass for this. So it saves a bunch of API shenanigans overhead. I think it's going to be good. So let me show you here. What I was doing here is I was working on this puffer env thing. And the idea here was to have just like a base class for puffer native environments. I hate this. Yeah, this is just terrible. So what we're going to do instead, and the main reason that I was doing this was because of this buffer thing right here. I couldn't find a clean way to have an environment be able to manage its own storage. I think I figured out a way to do that, but it's going to take a little bit of finagling because the structure of Puffer's infra at the moment, it's a little unintuitive, but it's not that bad until you get into the C environments. So you have this serial class right here. This is for running multiple environments in a loop. Very basic, right? Except that it also has all this like data buffer injection nonsense here, which isn't very good. And then it's run inside of multiprocessing. So you run multiprocessing vec, and then inside of it you run serial. On its own, that's kind of okay, but then you get into problems when you have these C environments that kind of do their own loops, and then you have to run multiprocessing, serial, Python C binding, Python wrapper thing, and then C environment under. It's just too much, and I hate it. So yeah, that's what we're going to look at right here. I'm trying to figure out where exactly I want to start on this. Yeah. Because I don't like the way that I was doing this before, to be honest. Yeah, this puffer env thing, it's got like this reset and this step and stuff. Let's open up an environment so we can see. Puffer lib, ocean. Let's take a look at a complex env first and then a simple one. Where's the Python? moba.py. Okay, so here's the Python file. You can see its subclasses, this puffer env thing. And what's the API signature? It's got render. I mean, this is pretty much going to match the Gymnasium Vec API, right? Yeah. This matches Gymnasium Vec API. And I think we can do that as well, right? I think so. So what we do, yeah, I think what has happened before is I had it confused. This puffer env needs to be not a vector class. It needs to be our native environment type. And then we have to have a native vectorization mode. So it's going to go multiprocessing, native, puffer env. I think that's it. Yeah, I think that works. Okay. Um, Let me see how we should go about this then. Let me see. Change this back to native, right? There's going to be a little bit of boilerplate before we get to the difficult decisions here, I think. No, this stays as puffer env. There's going to be a little bit of boilerplate before we get to this backend. This is going to be native. Puffer env, gymnasium. Yeah, this is it. We've cracked it. This is going to be the design. I can just tell. And then this assign buffers is not going to be needed, right? Is there ever a case where you need to instantiate this directly? Let me see. Env creator. Yeah, this API signature is just not required, right? I do think that you need num-m still, maybe. I think you do need num-ems. The lack of buffer is also weird, right? Yes. I just want to make absolutely sure I'm not getting something wrong here. So, the way that this works at the moment with puffers environments, right, is vectorization runs multiple environments either in parallel or serial or whatever. And in order to do this efficiently, data buffers are in shared memory, or they can be. At least they're a contiguous tensor. You need to pass slices of these into each individual environment. And the way I do that at the moment is with this injection technique. You get this injection technique. This injection technique is kind of nifty because you don't have to modify the initialization signature at all. You don't have to add this buff thing here. But I think it's going to be better to do it with it in the init. Let me just think of any potential downsides of doing this, because this is going to be a lot of code changes right all at once. I can do it all today, but it's going to be a lot of changes, and I really don't want to get this wrong. Let me check emulation. How do I handle it here? Okay, I set it to none here, and then I just assume that it's always injected. And then I have conditional logic. I see. Hmm. Oh, I think I even have, wait. Self.env. It's a big change. I think it's better. I'm not positive, though. To be fair, I do not have to make this decision for everything right now. I only have to make the decision for native environments. Is it guaranteed better? The thing is, okay, I'm being a bit incoherent here because this is complicated, but essentially what I'm trying to do is I'm trying to figure out how we get the data storage object, like the data storage arrays that we need for these environments into the environments. And right now, let me give you a practical version of what is the thing that's obnoxious right now. So this is the reset function for the MOBA. Every single environment has one like this, every custom environment. You see how we're making these environments inside of the reset function instead of making them when we make the environment? Yeah, this is because this is, unfortunately, because we do not have access to buff up here. Right? We do not have access to data buffers. It's not passed in here. So what this means is that we have to make them here, but we can't use them immediately because vectorization might overwrite these and might not. So not only do we have to keep track of this gross thing that should be able to be done automatically for us, but we also have to defer creating environments. This drives me insane. So I think that at the very least, we do this for native environments. To be fair, there's probably no harm in doing this for emulated environments as well. I'm not positive on that. Let's do it for native environments. Let's lock that in. Is buffer's not a reserved keyword or something, right? Yeah, no, we're good. It's gonna be buffers anyways, right? We'll name it later. Let's just get the initial implementation. So must define num-ems before init. No, right? We're just gonna do num-ems is a mandatory parameter. Let's see the signature that we're using. We don't need env creators, right? Or do we? I think we just need... I think we can almost keep this exactly. We can almost keep this signature exactly. The only thing that we need is we need to add I don't even think we need this star quarks, do we? We'll see about that. So now we don't need this has adder num ems thing. Num agents. We should not need num agents either, right? Let's see how we do this in serial. I think I'm going to be able to copy the serial logic and just simplify it. Yeah. Let's take all this garbage. Where it's going to be way simpler than this. So first of all, this is not a list. This is just m creator star args star quargs. You have to pass num ems like this. Buff equal buff. Something, I think it's something like this. And then driver environment. We never have emulation on for this, though technically we might end up doing something with emulation later. Check ems, sure. Agents per env. A lot of these things we should not need. A lot of these things we should not need. Let's go look at how this is done inside of multiprocessing. I guess we don't need agents per batch, ems per batch. Man, I haven't looked at this code in too long. Well, we'll see if, let's just fill stuff out and see if it's redundant. Native does not support async on its own, but you do get async through multiprocessing. Is that okay? I think it's okay. We'll see about that. Single observation space, single action space. Do we define these things at the moment? I think that we do. Okay, so this is why we needed agents per batch. We need to know the number of agents. Yeah. I think we can just do this gives you a total number of agents, I believe. Agent IDs. I believe you have to expose num agents as well, right? So you just do like at property this is kind of stupid, isn't it? These properties. Whatever. Let's not nitpick for now. We can nitpick once this works. Welcome. Hello. Currently trying to fix all this infra. Super inspired by your videos library. Thank you. If you haven't joined the Discord already, it's where all the dev happens. Often in the evening, I'll be hanging out in there just chatting about dev or whatever else. Really trying to scale the open source side of this. Been tinkering with PPO and tic-tac-toe plus shared memory. Cool. Wait, tic-tac-toe. Were you the one doing tic-tac-toe in the Discord? Let me see. Been lurking? Okay, that probably was you then, right? Yeah, I bet if you have the environment dynamics right, it'll just work. Oh, 600 members. That's awesome. Don't think so. Would be interested. I got distracted reading. What would you be interested in? I just, I lost track a second. My bad. There's been a lot of stuff going on lately. We have a hurricane coming in that we had to get all the servers to not get wiped out by them. The tic-tac-toe end should definitely just work if you get the dynamics right. Someone messing with tic-tac-toe? Oh, was that not you? Hold on. Oh, I guess is this not you? Tic-tac-toe. Yeah, there were a couple people messing around. I don't think I saw anybody actually do it. Yeah, RE Hurricane. I can't imagine. Yeah. It's kind of silly. We're gonna get the servers out of there soon enough because it's just like ridiculous. Yeah, I don't think that anybody... If somebody did it, they didn't actually do it in a way that we can nicely bind. So right now, the thing that we're trying to get a lot more environments to do, and this is something we're definitely looking for contributions on. So all these run, all of these environments here, they all run on web. Like I can open this and I can play it, right? And there's no JavaScript. Well, at least we haven't written any JavaScript for these. This is all just like WASM bindings for low-level environments. And we have a pretty clean way of doing that. It's a really good way to get into the project is to just like make a simple env, like go through the end-to-end process. And that process is getting easier every day. Like literally this infra that I'm building right here is going to cut out like one of the few final remaining annoyances with custom envs. cool. Can see how it would be a good. Yeah, we have people with 0 RL experience that just have, an engineering background that have made and gotten those environments working online in a day. Like the guy that did the Connect 4M that's on there pretty much did that whole thing in a day because, well, to be fair, we kind of try to meet people wherever they're at. Like you can just write Python environments and they will work. They just won't run on the web. You can push stuff into Python and then it'll be faster, but it still won't run on the web. Or you can push stuff all the way into C, which is not that hard. And then it does run on the web and it's super fast and everything is nice. We have lots of examples as well. Plus, I'm always around to help, depending on your engineering background. Pass this buffer in, right? Oh, right. There's like this extra layer of thing that I have to deal with here, right? Let me think. So you pass in. If I just run this on its own, am I going to be passing in a buffer? What am I going to be doing? I think I'm just going to be returning. Yeah. Wait, this is easy, right? Yeah, this is going to be the piece of code that we're going to need. Pretty much, I think. It's going to be something like this. So we'll store that. Yeah, okay, this is why we have properties. And then action space. Yeah, this does get declared like this. Agent IDs, okay. Now we can get rid of these obnoxious checks because the property will just get those for us. These two are good for now. This is just duplicated. And then this is just duplicated as well, right? And then we have num obs. Okay, this is all this code right here. So basically, this is going to have to go into pufferlib.environment or something, right? Like, probably here. And then this is going to be like def sign buffers env buffer none, like this. And then if it's none, then observations zeros. So what I'm trying to figure out here is I'm trying to just figure out a way for these environments to have like a convenient way to either take an input data storage structure, whoops, or create their own if needed. And I think it's just going to be num agents, obs, dtype, yeah, like this. And then I should just be able to like tab through all of this, actions as well. So something like this. There are gonna be some issues with that later, but we'll leave it for now. Okay, and now we do not need. We in the right piece of code here? Yeah, native. Native does not need assigned buffers because they already do this for themselves, right? And then here, this becomes infos gets returned here. And close like this. So pretty much this is going to be about the size of the piece of code that we need here, which is very slim. When I have something this slim, I actually question if this code even needs to exist, and probably will have some way eventually to not even require this, maybe. But this is pretty much what we want. Let's see if I can get this working with like breakout or something. Or Pong. Why is this here? Yeah, so this is pufferlib vector native. Buffer m, not this find. Port the buffer m here. Okay. Driver m. Also gotta rename all these. I don't know why it's like my Pong and such. No attribute driver n. Oops. Where's this? Okay, so yeah, right here, this needs to change. This is gonna just be oh, this is a good thing to include actually. When we make the environment, we should assert that it's a puffer env. And then what we do Just return native, right? Oh, back end of all this stuff. Let's just see if this does what this does. There's so much fluff to strip out here. Okay, so right. This is a good thing that we're encountering this because okay, this is actually kind of a thing that's a bit that we should think about here, right? So when you import this stuff, the only reason that I have this make function is to do the import dynamically, right? I think we're just going to say that all the first party environments will build. Because we can pretty much cut out all this nonsense if we just assume that we're not going to be stupid with our first party M. So like right here, right? You don't need this make pong function. You just return the class. And now here we have buff, right? Like this. And what we will do let's see. Okay, now there's additional keyword garbage that we just have to strip out. Are you familiar with TinyGrad? Yep. Cool project. You remind me of that framework. I'll take that. Yeah. Some of the TinyGrad stuff is a little bit too functional and too golfed for me. But the idea of trying to keep things simple as possible is absolutely required. Like, literally, in my head, once a project goes above a certain complexity threshold, like it's more complex than it needs to be, its value just drops to 0. Like, literally. If something is substantially more complicated than it needs to be, I kind of don't care what it is, it's just not useful. Try like this. Number of lines is slightly misaligned. Number of layers. Yeah, it's kind of both. It's tricky, right? It's very tricky. Because you don't actually have a... You want simplicity, but you don't have a way to measure it. Like, shorter code is generally good. Fewer components is generally good. Fewer APIs generally good. Fewer files often even generally good. It's just like, you have to be very, very dogmatic about simplifying, in my view. Like, you have to be almost fanatical about the simplicity of stuff. Like, I literally didn't do this for a week because I couldn't figure out a clean way of doing this buffer injection thing that I'm doing at the moment without making a superclass, a base class, and I'm not willing to accept the complexity of a base class. It's not even really taste is the thing, because it's very, very obviously, like, when you look at it, it's like, when something is simple, it's obvious, right? It's just hard to make it simple. I generally find that one really good metric for this is if the thing you're doing, if the way you end up building it makes you feel clever, you're probably wrong. That's usually correct. What happened here? Like, honestly, the best stuff, like, the best stuff I've built, I feel very, very stupid while building it. Like, you should feel incredibly stupid. Like, it should feel like this is so simple that it's trivial. Doesn't matter how complicated the thing you're working on is. The heck happened here? I just didn't get past a buffer, huh? Oh, I see. Hmm. We'll do like this. Reach. It's usually brother, but sure. Uh, did I already define this? Yes, I did. And yeah, we don't need this because what's check-envs do? Yeah, this is for vector. This is alternative. We don't need that. Okay, what happened here with self-reset? Async reset. I did something weird here. So here they define, or I'm the one that wrote it. Yeah, so you actually have to define this as env reset. This is this. And then here, this is very nice now because I can remove this garbage here and this one. So we get rid of buff completely, I believe, right? No buff, just observations. It's cleaner. Why is the self dot ready? It should be observations, right? Like this. And then this M step. I think it's like this. Isn't this the API? There we go. So this is the core of it, right? Is that we just have a simple pass through. We have this simple native wrapper thing. Instead of having a base class. And then buffers get managed through here instead of being like weirdly injected. Which lets us simplify our env code. Also at the same time we remove make function intermediates, I suppose. We remove make function intermediates for native envs. This will have to be implemented with multiprocessing as well. We'll have to do the same thing for multiprocessing. I'm trying to think if I want to do that first. I kind of want to do the multiprocessing thing first, just to make sure. I think I started on it, though. So I think it's actually not bad. Don't I have the type check in here or something? Right here. So you can see right here, this is where, yeah, this is where we want to do this. Oh, actually, this works incredibly well, the way I've implemented this here. I thought I was going to have to do some sort of loop over this, but I don't. I think I can literally just give it, right? Yes. How's that? I think you still need this indexing. I think it's like this, maybe. Okay. Namespace has no attribute truncations. Really? How is that possible? Observations? Hmm, that's silly. Okay, this is legit. This is legit that I didn't do actions. Let me think how I want to handle actions. I can just put actions in here, right? I can just literally just do this, can't I? Look at that. I'm surprised this works already. Um, these are not optimized parameters whatsoever, but you see 0% time in the environment. 0. Now this is going to be about environment integrations, cleaning this up, making sure I haven't screwed anything up horribly, and so on. But this is going to be the thing. I think this was the last missing thing for making all this easy. Because now, right now, I have it. It's very, very easy now for people to add new environments at whatever level they want. This removes the last piece of annoying, like, unintuitive, redundant boilerplate, I think. There might be one or two things left I'm not thinking of, but this was by far the worst of it. Yeah, like here, you can see that this loop is in Python. Yeah, so I think I answered this question. This was Nathan's question before, that you can't do this. Okay, so now I think that this should just work, right? Yep. So I wasn't able to do that before because the buffer here might change. I actually don't call assign buffers yet, do I? Wait. Oh yeah, I do. You also don't need self.buff. You can just do assign buffers. Like this. And then this all goes away. Let's see how much of this is now redundant. I bet a lot of this is now redundant. Render mode. Do you need to define render mode? Is that what happens if I delete this? Nothing. Yeah, so render mode has to be defined still. Is that a gymnasium thing? Hold on, let me just make sure I have not added that as a requirement. We want to really strip this down to be no more overhead than gym. And eventually we're going to phase out a lot of this stuff that is required by gym, but not yet. Where's their API? This is like, so they have all sorts of stuff that's never used. Like this stuff, for instance. It looks like, oh, it is part of it. Render mode is part of it. So we're not actually adding anything by doing render mode, so I think we're good. I think that we leave that as is for now. Okay, num-ems and num-agents. This is stuff we've added. We do need to know num-agents, don't we? Yeah, I think we need to know num-agents. I don't think we need num-ems. Let's just start commenting stuff I don't think that we need. Oh, all these things here. Yeah, we're gonna be able to clean all this up a lot. Observation space. And I think we use the vector form of observation space here, which is the single one. Let's try like this. See if this still works. Ems. Yeah. You're gonna see a lot of this boilerplate was literally just there because it was needed before in the reset. M.single observation space environment. I think we can just call this observation space. Cleaner. Num_ems. Do we need this? This will be num_ems. Don't need the self variable. Oh, I guess this is why you would want to have a num_ems, but it's not an API requirement, right? The only thing that's an API requirement, you need to know the number of agents. In order to know how big of a buffer to make, right? Okay, you can't see this because it's off screen. Let me pull this. So here's your random agent playing Pong. Eval now works. And there are a few other things, right? I'm going to try a couple things here. So first of all, let's just do, this is width, this is height, paddle width. All these variables here, these don't need to be saved, I assume, right? Let's see what happens if I just take all these out. Okay, so this still runs, still running a random policy. If I train, emulated. False if is native, else driver m.emulated. Oh, I see. I messed up the API a little here, didn't I? Let me think what I want to do about this. This is all stupid API compatibility stuff, right? I think what I need to do is I do need to go back to single spaces for now. But not permanently. I only need this for as long as we want Petting Zoo API compatibility. Eventually, we'll just subsume the other APIs within Cleaner and Faster Puffer API. But until then, we'll just, we'll keep it for compat, which I hate doing, but gotta start somewhere. Okay, so this is now single observation space. Oh, you know what I could do alternatively? I know what I'm gonna do. Even better. Watch this. So we'll just do... No, I can't. Okay, I thought I was gonna be able to wrapper it, but I can't. Because you need the raw environment to have this defined. Okay. Yeah, I do have to do the gross thing. That's fine. I don't mind doing this gross thing when I know it's temporary, and it's for like an external requirement that we're going to be able to delete pretty soon. So I don't mind that much. No attribute observation space. No attribute observation space. That is crazy obnoxious. But again, we get to cheat. We get to cheat. Okay, so we're back to having this working again. We also have this num agents thing. I guess we can put this like this, right? Because then what we'll just do is we'll just put it as a property. Like this. I hate the underscore. We'll just do that for now, though. now this works again. Now there's a little bit more that we have to do, I believe. Right? So we've got eval mode. Welcome, YouTube folks. Making Puffer Infra work today. Make it work real nice. Okay, so here's something I genuinely don't know. If I pass these buffers to the environment, but then they go out of scope, is Python smart enough to keep them around? I do not know this. How do I test this quickly? I'm trying to think how I test this quickly. Oh, I need these for logging anyways, though, don't I? Oh, these don't even need to be in Python at all. I mean, in Python at all. Yeah. He did all this from, like, MISC logging, which is fine. This is sketchy. Very sketchy here. Yeah, stuff needs a little work here. That's okay, though. I can do this right now. This will be good, this will be good to do anyways. This MISC logging thing. Yeah, I don't like this MISC logging thing either. It'll probably take me 30 minutes just to clean up Pong if I want to clean up just this one env. It's probably worth doing, right? Yeah. Okay. Let's start on it. Okay, so we've got Python Pong here. This is the wrapper. This doesn't need to be called Pong. I mean, CPong. So we'll just, oops. CPong. Leave this like this for now. These things here Yeah, these are nits. Wait, why do we even have these things allocated this way? Isn't this just jank? This is just straight up jank, right? There's literally no reason to have this. Yeah, there's no reason to have it this way. Paddle Y. I just replaced this with 4 values, right? Oh. This is not this contributor's fault either, I should make clear. It was actually kind of janky before. The way we were doing stuff, you kind of had to pass in all your memory allocations from Python. Did I just do that right? Yeah. I have to be very careful not to introduce any bugs while I'm doing this. Let me focus up a moment. Make sure I use the right one in each case. I'm gonna have to do this for a few different variables. The code will be substantially cleaner though, and the binding will be cleaner as well. It's not always gonna be super fun stream doing like crazy random M's, right? But this is important for having all our infra and all of our baseline M's the way that they need to be. This is ultimately like one of the most important things. If I have to do a little refactoring, it's perfectly fine. Though I am going to need some more caffeine if I'm going to be doing this. Score LR. Kind of nice in some ways. Just watching this very rapidly become simpler. And knowing that this is going to be for every single person writing custom RL environments going forward. I mean, this is demo code that I point people to. It's contributor demo code, but it's good. I mean, it was good for the standards of 2 weeks ago. And now, it's going to be much simpler. There's going to be even less weird stuff you have to do. Basically no weird stuff that you have to do at this point. This is kind of the last of it gone. You're literally just writing standard, like sim code. I'd be careful talking because I have to not mess up the indexing. Okay, so this is all this stuff here. Build local. I missed one. Okay, so here is our Pong game. It still plays. Let me make sure I can score a point. Yep. There it is. Oops. It's very difficult for a Pong game as well. Huh. Oof. Okay, it seems like it works. These are standard. As just raylib or raylib depths. You can tell that there's nothing in here that's none of these errors are in puffer. It's just an internal build. What about this misc logging thing? This probably still has to get passed in, right? But we're going to be able to do this for now. Oh yeah, I got it. Damn it. So much stuff. The signature changed. To be fair, it should actually be completely possible to auto-generate most of the Scython. Almost all of it, really. I just haven't gotten that set up in a way that I like yet. So, doing it manually is slow but easy. Versus having like a broken auto-gen tool. Okay. And we take... This goes away. These lines go away. Can we build? LR. No attribute. Right here, this goes away as well. $17 args given. Shoot. Oh, I bet it's right there. Seg fault. Seg fault. Really? Observations, rewards, terminals. Oh, because I am dumb. Did I forget VX and VY as well? Almost done with this one. I think the other one should be substantially easier as well. Wait, did I do this right? Yeah, I did. On the bright side, we actually we simplified this quite a bit, this code. Okay, does our Pong game work? Pong game still appears to work, right? It's kind of fun, to be honest. And then we have to do Pong.h, vx, vy, Pong. Yeah, and then we don't allocate all the variables, right? Hopefully they get reset cleanly. I actually didn't think about that. We'll see if they do. Okay, so here is running through Puffer random policy. This appears to work. Let's see training. Training also works. Very good. So this binding layer is kind of annoying that this has to exist still, but not bad overall. We're gonna actually just port real quick the just do num_ems width and height like this. Then this will just be cms equals. What we're gonna do is we're gonna port the loop to BNC. Not strictly necessary because of how fast this thing is, but I do believe it'll be cleaner. Like there won't be all this indexing; it'll just be in Python. Like this. Oops. cms.reset. And then this is going to be .cms.step. num_ems. All right, and then we will do. I did this somewhere and I don't remember where. Maybe it was the MOBA. Let me see if I did it here. I don't think I did it here, did I? Oh no, I did, right? No. Well, whatever. We'll just do it here. So what this is going to be is this is going to be pointer. Okay, and then what we're going to do is self.env size of Pong. And then we're just going to do def int I for range in num_ems like this. Of I. I think I need to find this because there were a little things there were a couple things that were a little tricky. The grid. Star M's. Was this it? This is very odd. Yeah, what is this? Why the heck do I have it like this? M star star M's. That's really weird, isn't it? Oh, it's probably because... Yeah, that's fine. We don't have to do it that way here. It'll be easier. So we have this calic like this. And then we make this pong. And then this gets knitted like this. Everything's coming together here. Everything is coming together here. Yeah, it thinks that this is Python and it's not. This is reset like this. This self.ems is 0. Make client. This. There's really nothing allocated here, is there? In the init here. So I think it's literally... I think we did it right. If this one works, we'll do the whole rest of them like this as well. Oops. Okay, this still runs. And then... See? Get some errors. Cannot convert Python object to Pong star. Right, so this was the obnoxious thing I gotta figure out. Well, wait, this isn't not even imported. Okay, now we get a better error at least. Now we get one error. And, oh yeah, we just need to cast, right? That's good to me. Not subscriptable. We get to get even easier here. Whew. Look at that. How's train? Train still work? This should now go at literal millions of steps per second. Not training because we're bottlenecked by bad params, but the env will go real fast. Okay, so what did we do here? We pushed the loopings, pretty much we push all looping from Python to Python, and then that runs pure C, the env is in C. This is a very nice separation of things, right? Where you have env code is in C, external loop is in Python, since that's a binding anyways. And then you have very simple, very simple wrapper code in Python. Let's get the logging working real quick. And clean this code up as well. 98. Self.tick. So these sums, this should all just be done in C. All these stats. What do I think about that, actually? You could very easily make like a shared stats object that all these things can increment. Or shared stat struct, rather. I like the idea of being able to easily exfiltrate data from C, and I know exactly how to do it as well. There's no reason not to. Right? Yeah, I think I know. We're gonna do something kind of cool here. Yeah, we're gonna do something kind of cool here. I'm gonna use the restroom real quick. Remind me to unmute my mic when I come back if I forget. I'm gonna grab a quick drink, and we're gonna do much better logging than this. It'll be faster, it'll be simpler, everything. So I'll be right back. Did not forget to unmute Mike this time. Hello, folks. RL Infra is going to be in such a better place after this. I mean, just like the M's are going to be so much simpler for contributors and such. I honestly really should just push to get this merged today. That'd be the best thing. Because you guys really should have this already. It's going to just be so nice for everybody. Like all this boilerplate. But we're going to do something really cool now. I'm going to do something really, really cool now. Let me show you this. So, type def struct logs. This is 4 integers here. And you can see that there's just like this sort of structure, right? And this is unsigned int. No reason for it to be unsigned. This is actually a really cool thing for folks to learn. One is round is over. But what numbers do they actually want? They want reward sum, finished rounds, tick, and bounces, and win. Okay, so there are two things I can do here that are kind of cool. One is that I can have one shared logger between across all the environments, and I can have them update it without screwing each other up. I can do that very, very cleanly and easily. Or the other thing, which I think is going to be more appropriate here, is I can have one logger instance per environment. I don't really like either of these options. Bounces. Kind of want your episode returns, right? Give me a moment to figure this out. I want to make sure we do this in a way that is good. Logging is always a pain. But the cool thing is that I have a really good way of sharing structs and arrays of structs with named elements between Python and C, and Python as well. So we're going to be able to have very clean syntax. I just have to figure out the way I want to record this data. You recaffeinate. Let me double check one thing in the meantime. Let me see here. I'm just trying to figure out a clean formulation for recording episode returns, right? Let me see the other stats recorded. Bounces, wins. I could get fancy with this. I don't necessarily think that's the best idea. Intuition tells me that it sounds like a good idea but isn't. Okay, let me just at least talk through what's going through my head at the moment. So we need a nice way of recording stats, right? I can make a log object, which is just a struct, which can contain, various elements. I can very cleanly pass that to all the different C environments. So that, let's say that we just want to record a total number of bounces or whatever across all the environments, we can have them all increment that same struct, or we can have all the environments increment their own struct, so we can see the average number of bounces per environment at any given time, for instance. Problem is that the environments are going to reset at different times, right? So you either need to, when that data is reset from Python, you extract out the information that you need into a list, or you would need like a similar type of variable length data structure in C. So if I wanted to get very complicated, not really that complicated to be fair, but I could just add like a simple stack type thing where the environments can just push end of episode logs onto a stack. And then from Python, once in a while, you just average everything out over the stack and clear it. Pretty easy for me to do that. I don't know if that's worth it. That seems like a lot of complexity overhead for something this simple. But this has been a persistent pain in the ass. So maybe. Let me think about this. What would this actually require? I think it'll very quickly get more complicated than I would like. You'd need some sort of internal log structure for the environment to keep track of the stuff that it's going to report at the end of episode. And then at the end of the episode, it's going to have to like stack push its logs, which is really just going to be an array. I could make a little Python function to record from there to clear the stack and return all the means or whatever. You don't always want means. Sometimes you want sums and such. Is there anything I can do that's simpler than this? If I just ignore, if I just say that this is just going to be for Pong. So what's it need? When end game is finished, you want to know whether you won the game, how many bounces there were, it ticks, maybe some reward or something. It seems like you need at least some piece of machinery for this. The stack idea is really not looking that bad. What if I think about it for a more complex end like the MOBA? Not that bad still. Even more complex env actually works very nicely with multi-agent envs, depending on how you want to define such. You can cap the buffer size. I kind of like it. I kind of like it. You just make a log struct The environment can maintain one or several of these, depending on the type of environment it is. Or it can maintain none of them if it doesn't need to. And then you need to have a stack, which is just an array, just a few lines of code. Are there any reasons not to do this? Well, if I ever want to do multiprocessing in here, that doesn't work, right? Yeah. Hmm. Well, I guess a lot of stuff doesn't work anyways in that case, though, right? And actually, maybe we're still fine. I'm not going to be messing with that for a while anyways. I think for the immediate term, it's probably the simplest way of doing some form of logging. Basically eliminates all of the remaining boilerplate code in Python. I think that's pretty good. I think that's worth doing. We'll see if I'm horribly wrong, but I think it's a very small amount of complexity. Done. It just needs to know tick, win, bounce. And tick. You can even do multi-type like this. And then watch this. We can do type def struct. We'll just do log stack. Index. Length. Allocate. Stack. Size. There we go. That's pretty good, right? Does this need to be allocated like this? It might not need to even be allocated because Python will manage that, won't it? Well, hold on. I think this is probably right. Push log. Also, it probably shouldn't be a stack. It should probably be a circular buffer. Yeah, this will be better. Circular buffer is actually going to be harder, though. Now I'm thinking about it. I think I had it right before with the stack. Yeah. It's a little awkward. It is a little awkward. I think it's okay, though. Log. So then we have... We really don't need push and pop then, do we? So it'll be a log buffer, but it won't be a circular buffer. Let's see. Okay. Free log buffer. This. Add log. Okay. Then we do if. Turn. And then the question is how we can do like log aggregate. Can you return a struct? You can return a struct, can't you? Yeah. Hold on. Ah. Bad. Okay, I was unsure about the lifetime of this. This is what we wanted. Yeah, return by value. Good. Glad I checked, but we are safe here. And clear. Log buffer logs. And then what we would do is log. In. Okay. So we go through all the logs. We do it like this. And then we do for return log. But we also have to go through a second time. And we have to do log /equal. Is that going to do integer division? If I make them all floats, it works. What do we think about this? So I added to this like 45 lines of code. And this gets us, oh no, because I also have to include this. So I added a screen of code. Is this worth it? You add one screen of code, and then what's going to happen here is we're going to be able to get this log from Python. And then we can literally just expose this aggregate and clear function. We have to guard there. Kind of a specific piece of code. I'd have to think about how, if there were a nice way to write this reusable. I don't think that there is, and I don't think it really matters that much. But you have a buffer. This essentially gives you variable length logging. Let's try it and let's see how much stuff it adds to the code base. I think that's going to be the way to do it. So right away we need both of these type defs. I'm going to ignore code added by type defs though because I think it's going to be able to be auto-genned. So we put right here C type def struct logs. Allocate log buffer. Add log. We do not need this one. I think that this is good. So we make log buffer star logs. And then we do allocate log buffer. num logs. Fine. Can you pound define in Python? I think you can. Like this. And then I will make like a def log, I guess. Log. Turn log. This is actually kind of nice. Because now that I'm looking at this, you don't even have to pass in the memory from Python to do this. You might want to. It gives you more access to it. But you don't have to. Oh, we also... I forgot that we get to delete a little bit of code for this as well, don't we? We add a couple things and we delete a couple things. So we just get to do like log. You need to have the pointer to the log buffer, I believe. Log buffer. And I think you can just do... I think you can just literally do this. Get rid of misclogging. Oh, we should put the log buffer size in here, right? I think that this is, right? Feels like a lot of code for just Pong. Some of these things I think we're going to be able to remove, though. Alright, so this is nice. We get to do env log buffer. I don't think any of this needs to get changed. I think actually... Let me see. Yeah. I think that we don't have to do any of this in the reset of the round. We do this in the overall reset. So we just get rid of this. And tick. 0 is weird. Is that the right syntax? I thought it's just like this. I thought it's just this. Maybe with a cast needed. We'll see. We do not need this. Okay, well, it's not used anywhere else. So what did we want? Numb bounces, win, tick. So some tick, bounces, score, I think. Would make sense. Do we need numb bounces? I don't think so. Some reward, score, and tick will do it. We can easily add stuff. Fine. And then I have to add stuff in there, I assume. Add. We add the log to the buffer. Log. Logs. We do log star buffer. Clean some stuff up here. And I'm going to pass this by... I generally make it a rule to not pass structs by value, just because it leads to bad outcomes. So we'll just do that. Okay, so we've got add log here. And now all I have to do is figure out where to update some reward, score, and tick. Log score plus equals 10. Or plus equals agent wins. Hold on. Plus equals 1. To do duplicated code. Okay. Well, you don't get any points for this. Oh, I see. So this is, yeah, it is just the code doesn't, okay. Log this. Reset. It's 10.0. You get this bounce reward here. Noticing some differences from the original. Collision with wall lose. Or L. Handle collision on right. Log tick plus equal 1. And some rewards, score tick. I think we got everything. I'm pretty sure we got everything. Well, we'll find out very soon. But then this will basically, with the additional infra changes we made, this also doesn't need a name. This is just some reward, score, and tick. Logs. And we have some genuine errors here, I believe. We'll debug these in pure C. Not assignable. Not a pointer. H53. Expected expression. Isn't this, I thought that this was valid. Am I dumb here? TCG env equals. I thought that I had that. Hold on. The error? Expected expression? I think you can just cast, yeah. Well, it's not a cast. There's something weird going on, but I think you just have to do. If I just do like this. Yeah, that works. And let's see if we can run it. It appears we can play the game. Oop. I don't know if we need all this here. Well, but this is fine for now. Build. Misc logging. Misc. After terminals. These should really be auto-generated. Get rid of misc logging. Look at that. We got rid of basically all of the jank things. And we're literally going to be able to just do if self.tick, then we do info equals this. Okay. Well, it's stuck. So something is weird. Why is it stuck? It's stuck there. Let's not do multiprocessing. Look at that. So there's something weird here, but this so far is good. Let me see what we call it. Episodic. Episode length and episode return is what we call it. Episode return. Episode length, and then we'll do score. Because these can be different, right? Let's go. Welcome. This is going quite well. I think that we almost have this. We almost have the end-to-end demo done without all the jank, which is going to be very, very nice to have. I mean, like, we've had this working, like, we've had good infra for the last, months, but, I think it's going to just get way, way better today. Of course, it took me taking a weekend off to clear my head in order to be able to figure this out, but, results good. Oops. Episode length. episode return. Okay, if we call train now, what happens? We freeze. Interesting. Do I have a while anywhere? Segfault. Interesting. Well, we can pretty easily figure this out, right? Extra compile args. Okay. Let's see where this segfaults. There we go. Interesting. Did this not get allocated? Oh, I guess not. Well, that's easy. Terminals. Self.logs. Let's see if this works. Lovely. Now, infos are not being reported. Let's fix that. We should definitely be reporting infos. Like right here, right? Let's see. Fixing Pong. Much, much more than that, my guy. Much more than that. Fixing pufferlib infrastructure. You're gonna love the new environment. The new environment integrations. It's so easy. It's like so much easier. Welcome as well, Bet. I'll show you in a second. Let me make sure it actually logs correctly. For some reason, we're not getting infos back. Let's see why we're not getting infos. Just got home, completed. Telling people score. Completed all performance reviews. Oh, this is not Puffer. My bad, yeah. You can be a boss, but are you the boss? Is the question. Chilled a little bit. We're pretty good. I did a couple extra workouts this weekend. My folks were in town, so did a little training with my dad. Shoulder week. Ran up and down a ski hill. That is hard work. Indeed. Let me see. I'm trying to figure out why this info thing isn't getting logged. I'm tired of rank 20. Yeah, man. The thing is, you can actually just do that. You can literally train to do that within a few months. I mean, it's hard, but you can do it. Could do it. Yeah, but you can train to do it in a way that you have a very low chance of injury. There's no excuse, right? It's like if you want to do it, you just go do it. Personally, I think that like it's a good thing to train to do a marathon. Longer distance, like the 50K actually did some like more damage to me. But like a flat marathon or like a mostly flat marathon, totally achievable. What the heck is wrong with this thing? Yeah, no, the thing was the 50K I did took me 7.5 hours, which is at least probably like a good hour, at least a good hour longer than it should have taken if it were flat. Very weird that this is I assume that I'm just forgetting the format. Infos. Oh, it's because it's a list. Yeah, it's a list. let's add a check actually for that. Rip info, stepper with enduro. Need the format right. So the numbers. Yep. I add checks for this stuff in new APIs when I can. Like right here, for instance, we're just going to assert is instance .info sticked list. There we go. Few other issues. Yeah, let me figure this right now while I'm on a roll. This is going to be a huge difference for the library right here. You'll see how clean it is. You can actually kind of see already. Look how much less code is in the Python. In fact, I'm going to be able to delete all this stuff up here as well. You'll see. Observation out of range. Yeah, uninitialized. Most likely your double check that your observation types and sizes are what they say. Because if you accidentally change the ob size and you pass a pointer, it's not going to check the bounds for use. Ping pong indeed. Where's the stupid thing? Oh. Yeah, infos is vec format. Yeah. Let's do this. Does it show up now? So, no idea if this is correct or not, how easy this is to train, if default hypers are any good. Info does show up. Yeah, we should probably check on to make sure like the end-to-end training is good. But check this out. So this is the Pong environment. And in fact, let's real quick, let's just fully demonstrate here. Tick, report interval. I don't know why they have the terminals in uint8 format like this. Yeah, we really don't need... I'm sure we don't need this. Is there a reason it has to be unsigned char star? What do we do by default? Is it a float? Don't make it binary. What do we do by default? We have it as a bool. What's annoying about having it be a bool? You gotta be kidding me, right? Like, include standard bool. You don't need to pound def bool. Yeah, I'm making it a bool. That's ridiculous. We're not dealing with that shit. Yeah, just do this shit correctly. Okay, so there we go. The int. Just include standard bool. Okay. Cool, we can play. Solid. Long game. Hold on. No, hold on. Chill. Cannot assign. Type unsigned. Char star. Interesting, that's a compile error. Well, I don't think it should be. Let me see. To avoid... No, we should just figure out how to do it correctly. Unless it's, like, cursed, but it really shouldn't be. Oh, I know what it is. Oh, is there not an init function? I'm sure I forgot to change... Oh, it's the header, right? Yeah, it's their header. Look, that's literally it. Just a header. What do we have here? Okay, this is interesting. Assignment to bool from incompatible type int star. So now it compiles. Let me just make sure we're actually passing the correct type here. Warning is not /ignore in C. Python warning is like, hey, maybe take a look at this if you get a chance. If not, no big deal. Warning in C is you're about to blow your foot off with a shotgun. type bool. Let me figure out why this is warning. Where was my warning? Okay, so this is not what we want. Cython has its own weird... Yeah, this is be very careful. Underscore bool. That's a little weird. Ah, okay. That's interesting. Yeah, I mean, you're not expected to figure these things out. But that doesn't mean that I'm going to leave pufferlib having something stupid in it, right? Because I can't figure out how to use a fucking boolean. I'm just trying to figure out if there's a reference. Normal thing. The normal thing to do in C is to use a bool. We're not quickly approaching a pound of fun. It's actually incredibly funny to me that as soon as you go from C Stack Overflow to like Python or even Python, the quality of the answers just become garbage. Well, no, it's because bool is not a standard. Like in order to use the bool, you need to include standard bool. I don't know why that is, but it's a C quirk. Let me try something. Let's see. Should just be bool, shouldn't it? C typed. This is fucking wrong. It is crazy, this AI overview thing. I don't even know how much money they're burning on it, but like every single Google search, they just generate some garbage. Well, to be fair, the reason that people can't use Google is because of all the AI generated garbage. It's actually incredibly difficult to find anything these days. I'm trying to think what's the easiest way to fix this. You're probably right that you can do an unsigned char internally. Let me see what happens if I do that. But I don't want to use an unsigned char from Python, if that makes sense. We are reading about RL for LLMs in our ML reading group at the moment. Are you interested in that area? Quite a different set of performance characteristics. I mean, I can provide some input, I'm sure, on a few different things, but you have a very different problem surface, right? And honestly, like, the way RL is being, it depends what you mean. If you mean RL to train LLMs, you're in a not a fun area, because what you're doing is you're taking the weakest part of RL, um, and you're using it in a very expensive area. Obviously, it works with O1 and stuff, but it only works if you have unlimited money for now. That said, I did talk to some people last week that had more reasonable ideas on places to use RL, but like the O1 thing, it makes sense what they're doing, but it's going to be very expensive. Inference time compute, guiding the tree of output using, yeah, you're looking at O1. Yeah, that's the one thing that you can't do. Do you understand why not? Because what's going to happen is Python is going to use a byte. It's probably going to use an unsigned char to represent that bool, and Python is going to use a cint, which is 4 bytes. So you're going to have wrong numbers of bytes. Okay, what I just did seems like it might have worked. We'll have to see. Not something I would expect you to know, mind you. Okay, so we have a true here. Hopefully I have this correct. Okay, we're definitely going to have to do a little bit of tweaking to make sure I haven't broken anything here, because I want to make sure that this thing can actually train, which can actually end up being non-trivial. But I just want to show. I'm gonna have to go make a shake and stuff real quick, but I just want to show something real. I want to show something off. Unsigned char in C and Python. Yeah, so I use a bool in Python, so I don't have to do something stupid in Python, right? And then I cast to unsigned char, and I'm assuming that the byte structure is the same. I would think. I'm not positive. It could be breaking stuff. We'll see. Well, do you know that? Between Python and C, yeah, but you don't know that you don't know how a Python bool is represented. If it's represented just as a single byte, or if it's like packed or whatever. I assume it's probably a byte, but I don't know. Anyways, don't need this. SciPong. Okay. Let me now show you what we've done here, because this is actually pretty cool. So this is just a test at the bottom, so you can ignore this. So you basically have a screen of code for this binding right here. You see this? And it has a whole bunch of options. And then all it does is it passes all these options to the C wrapper. It includes logging right here with an adjustable log interval. And it includes the gymnasium defs. You see how slim this wrapper is? And then in SciPong here, this stuff at the top can be auto-gened. It's literally just, defs from the .h. Here's your SciPong. You can see you make these m's in a loop and init them. But the make function is literally just an instantiation of the struct. There's no other jank there. You've got your reset and step, which do loops. You've got render function, and you've got this aggregate and clear log. And then in pong.h, you have normal code without really having to do anything specific for the fact that this is an RLN. Just a struct, has a bunch of data, and has the logic for the game, which could be substantially compressed. The game logic could definitely be compressed. High level, though, very simple. And here's the renderer. And this all works. And the way that this now happens, the .c is for a test. The .c is a test, so you can run locally. It also is used for the web thing. Also, this now can run through a native renderer, meaning there's no more serial. You no longer need a serial layer. So if you just want to run this on one core but ultra high throughput, you can just run through native. The .c it's the same as before, bet. So you have this native. This native is a very, very, very slim compatibility layer. And you no longer ever have to do anything with serial with native environments. You never have to do any of this code here. And then you can optionally run it in multiprocessing. So you can run multiple natives. You run one native on each core. You get a nice performance boost by pushing the loop from Python, I assume. It depends on the environment. Most likely for Breakout, you will. I mean, for these environments, you will because they're single agent. Also, I honestly think it's just cleaner because you treat the Python as like a binding intermediate layer and you keep the crap out of the Python wrapper. It's nice. So vector.py, native environments, massively, massively simplified. Massively simplified native environments. The base class for puffer ems is an abstract class for all intents and purposes. These properties are API compatibility only. Otherwise, I would mark this abstract. So there's nothing hidden in here. There's no like base class bullshit. This assign buffers thing, this function is used to handle all of the data allocations or the data assignments. And then you don't have to care about any of it. You want to write your environment, you can just write your environment with no boilerplate. We also managed to get rid of the make Pong function, this thing here. We don't need it. We can just directly use the class for this. Wrap with stats wrapper? Nope. You don't need a stats wrapper either. No wrappers. Native. Your environment layer is the environment you wrote. Runs raw. Native. Couple little compatibility things for vectorization API. Really, if I wanted to have a base class, I could make them both compatible easily. Let me go check on that. Hmm. You know, it's funny. This is so close. I could almost just make this the base class. I'm actually very tempted to. Because it still really doesn't do any magic for you. I'll think about that in a bit. I might actually be able to remove native entirely and just have puffer M's also work as Vec M's. I'm not 1 to 2 steps away from making a registry. Please shoot me when I do. Welcome that guy. This is honestly so close. Is it worth it, though? Yeah, I can make a base class too. Is it worth it? Is it worth having you subclass a puffer M that has this minimal amount of logic in it, like this stuff right here, for the privilege of being able to use it with vectorization immediately without this additional native object? Is that worth it? Well, of course it works. That doesn't mean it's worth it. Bam. Garbage code. Hate the stupid gym registry. It's honestly terrible design. Gonna go run. Enforce base class for convenience. Well, no, you need to have a base class. But the thing is, it can be an abstract base class. Or I can eliminate this whole native thing here by making it a very slightly more complex one. I'm actually thinking about it. Start with less. That's the thing. I don't know which is more complex. I'm always going to pick the simpler one. I don't know what is the simpler one here. If you want these checks, wait. If I did make it a base class, you'd have to like late call super, which is kind of disgusting. Or I'd have to make these things hooks. More or less magic for the user. I don't know. The thing, well, no, it's you don't want stuff to be magic. But the question is like, You also don't like these stupid wrapper classes that don't seem to do anything. Just co-star Pufferlib. Signing off. Thank you. Yeah. Folks, please do star Puffer if you find any of this useful. It's all open source, it's all free, it's where Bet linked it. It really helps out a ton. Fewer default. Well, I already have fewer default wrappers, that guy. So the thing that's going on here, right, is I'm cleaning up the code paths for native puffer M's. So I've stripped out serial. You no longer have to go through this loop with like the bigger serial class for native environments. You go through this native wrapper here. The thing is, if I just switch your base class, if like I just take the little bits of logic, because this is barely anything, right? If I put this into puffer env, which you're currently base subclassing, but is currently like abstract, then you don't need native. Puffer env just functions as a vec env or as a normal env. Yeah, it does. It sounds nice, right? But you have a base class, and it's not just like an abstract. I mean, I guess like you can't even tell it's a freaking abstract. You can't even tell it's an interface versus a base class or whatever with Puffer anyways. You also need this joint space and shit, though. It's not just dependency-less. I might go try it. I might go add this stuff into the base and then see if it's better or not. Let me use a restroom real quick. I'll be right back. And then I will see what I can do here. We're very, very close to having, like, super, super clean, simple everything. In fact, I think it already is with this. It can only ever be a little bit better. But I want to think about it. Because then you wouldn't need to have something called native. It would just be native, which is nice. Anyways, be right back. Whoops. Mute button. You know what? I like it. And the reason that I like it is that it's one less layer, and it takes us... It's going to allow us, once we ditch eventually like gym or petting zoo APIs or whatever, to like put everything into that format without like multiple layers that have to be maintained separately. So it'll allow us to co-optimize. We're going to try it at least initially. Is this done variable needed? It's probably not redundant, actually. This one isn't. Self. Yeah, because this will be really nice. It'll be so easy to just strip stuff out as I'm done with it, right? Don't need no mems. Yeah, you can tell that there's going to be less code actually by doing this, right? It's going to take me a second, though. Oh, look at this, actually. This goes at the bottom. Okay. this flag as well. These flags. Let's just copy them for now. Copy these for now. Whoops. Okay, so def init. Creator, args, and quargs. I think it's literally just, you just do like this. Right? I think we'll do buff equal none. And then we'll do oh wait, we can have assign buffers happen right here. If we're gonna commit to this. Which is the thing I didn't want to do earlier, but it's worth it if it makes it. So yeah, essentially I ended up circling back around to the thing I started with. But I cleaned it up enough along the way that it's no longer too complicated. So I sort of ended up where I started, but in a way better way. And actually, right, we can take this assign buffers. This just goes into puffer. We're gonna try this at least. I really hate subclassing. But I think in this case it's gonna give you so much. We'll see if this sin is worth it or not. What's the dot format? Let me use this in so long. Yeah. API usage error. Yeah, API usage error. Yeah, that's gross. Let's just do it like this. Properties. Star quarks. What about this? Okay, so this assigned buffers is going to be super buff. What do we think of that? Not implemented error. It's kind of dumb that it's implemented as a property like that, right? Yeah. Because, like, I don't like properties unless they're default ones. Let's just do this, right? All the required properties. all our own properties that we want. It's like somewhat annoying because we'll have to do the extra checks, right? But I think that that'll bite more devs if I do it the other way. You see? I messed up right here, and the API actually told me. Has adder. I think this will give you a reasonable error already. Self.action space. Cutting it down, cutting it down. All these self.env things go away. Very clean. I think that this is one place where it makes sense, because it's Python anyways, and you're going to have an interface anyways, even though they don't exist. Yeah, so there we go. Now this is training. env.done. Yeah, I think you do need this. You do need done at the moment. Just because they handle their own resets at the moment. Not done. Reset step and close. And then we have our async reset, our send, and our receive. I don't know if these are correct though, right? Are they? Don't we need to change the flags around a bit? And pre-check. We're not going to be able to do these, which is obnoxious. We'll have to figure out a way to get these into native. Yeah, that's kind of rough. Flag. We don't need these flags anymore. Take some guardrails off, that was annoying. A little faster. Maybe. Maybe not. 85 lines. It's not bad. It's not bad. This is the price that we gotta pay in order to have full native VEC. Like, I think it's a good price. This is solid progress. I'm trying to think how much more stuff I want to do. I do need to go get a shake if I want to have any chance of, yeah. Let me think what order I want to do stuff in. Okay, you know what I think I'm going to do? I'm going to go get a shake. I'm going to spend just a little bit more time, and I'm going to try to actually get this Pong M to train. And that's going to be the main goal for today. I'll be right back. All right. Goal is get Pong Env training with the nice new fancy format. And then that'll be it for the stream. Then I can get other stuff done. Let me figure out what I want to do with this. Okay, so we have 512 M's. M's. Do I just change this to 4096? Is that what we do? Hmm. And you can literally run it synchronous if you want, can't you? That's funny. Because it's just so stupidly fast, you literally don't even need to do anything, right? 1, 1. This is what we do. 48. 64K. This 16. 380,000. It being mostly 0 is probably a factor of, hold on. Now the reports are going to be very infrequent. It only logs full games. Yeah, and you're running so many parallel M's that, like... Let me think how I want to do that. Well, also, hold on. The length is screwy as well, right? Game length is screwy. Maybe just no games are finishing. So the episode length would have to actually be longer, right? Episode length is going to have to be longer. Let's just add some printfs, right? Whoa. Episode length, score. Huh? So it's not scoring any points. So here you can see we do actually have the score increment here. Then you have the add log before reset. Then the aggregate and clear. Well, just for now, let's do something about this. We'll just do, oops, redo the setup. Okay, so this is just not reporting correctly. Divide equals. Oops. Okay, so now we're seeing log here, 0, 0, 0, right? plus equal. Something's weird here. What if I go up here? Oops. Redo setup. Okay, you can see we got big numbers, right? Is this just like float division bullshit? Oh, no, I'm just stupid is what this is. This shouldn't be a loop, right? Yeah. There we go. Close not implemented. We'll fix that. Initially, though, .48 environments. 32. Fix. Well, let's just try this. Amusingly, you go all the way down to 18,000 steps per second with the garbage batch size. Bottlenecked almost entirely on forward. And MISC processing as well. Yo, what's up? Back home, can go over Go. Oh yeah, cool. Want me to make a PR? Shogobath was logging game endings. Yeah, go ahead, make a PR. I'm finishing up this stream, and then I got one or two quick things to do, and then I will hop on voice to fix that. I have really cool updates, actually. I'll show you real quick. Let me undo this mess. So this is what the Python bindings for Pong look like after cleanup. This is the whole Pong binding in Python. See how much less boilerplate there is? It's like a third the length it was before. It's also a native format, so this actually, you can use this as a vecenv as well without using anything else. So for ridiculously fast environments, you can literally cut out, another layer of the stack, another 1,000 lines of code. I'm pretty sure the whole Pong, like the whole end-to-end of Pong, running with the whole demo, including the implementation, under this version, is less than 2,000 lines. It's not gotten a single point. Did you ever figure out Boolean? Yeah, it's obnoxious. What you do is you use a Boolean from Python side, and then you just cast it to. Well, to be fair, I don't know. That could be the reason it's not training now. But I think you can just cast to unsigned char in Python and C. But you definitely don't want to do. There's some other ways that are definitely wrong that I found. Work on PR, 3x the speed with some items we can. Okay, great, yeah. What's current speed? I think pretty much anything should be able to get to 1,000,000. This is running on my local desktop, otherwise this would be at around 1,000,000. Unfortunately, we can't test that for a few days because puffer boxes are in storm surge mode. We'll get you access to one once they're back up, though, as you've been, doing all this stuff, and you could probably use a test box once in a while. $300K, 90K on 18 by 18. Getting wrecked with how I implement checking legal moves. Oh. I'll look at that with you, no worries. Yeah, I'll look at that with you. Yeah, this is not learning. Let me see if it's actually getting the observation data. That's training speed, not M speed. Well, you should check your M speed then, right? To see where you're like, are you getting bottlenecked by M? Or is the M fast? That's a key distinction. Definitely key distinction. So this did actually go up a bit. You can't really tell though, it could just be random. Get rid of track. Well, that's something. I think I found it. One to 2 mil. Checking. Well, when you try to get to 2 mil, you're going to get bottlenecked by a CUDA transfer bandwidth. So you're not just going to scale infinitely like that. Oh, MVS PS though, yeah. Yeah. You should get a profile on M though. If you have time right now, before I finish this, and like it's gonna take me like 20 minutes as well to get the other stuff after this, but before I get to the gym and I can chat with stuff. But I think I just found the error in this. We'll figure out if there's a better way to do this cast. On running test performance, 650K 9x9. Possibly we can make that faster with, I'm assuming you haven't put the loops into C yet. Which is what this is, by the way, this is what you're looking at is the loops in C. Or Python, really. You see how I have the M's allocated in Python, right, in a buffer? That'll help you with, you're going to get hammered otherwise by the Python loop speed. But it could just be the checks. We'll look at it. Ah, there we go. Just wasn't doing handling observations correctly. We'll see if it actually trains now, or if it's just like better failure. Remains to be seen. Zoom. Kind of suspicious it hasn't figured out how to score a point yet. Has been training for plenty of time. There's some type of deficiency. Frame skip. Could be the actions, maybe. Actions look good. Maybe we'll just have to view the model. Still learning. Oh, there it is. It got a point. Pong is usually a hard takeoff environment. Hopefully it does something decent by the time it finishes training here. Definitely can learn, though. It's crashing back down. We'll take a look at the policy maybe real quick. Oh, look at that. It's running the eval. Close not implemented. It should have saved, though. Ooh, look at this. Here's our policy. It's not great, but it's definitely learned something. Way better than random. Oh. I think I might still be slightly better than it without having done any sweep or anything. But cool, we'll be able to do a sweep on this, and we'll be able to have this solved. And that'll be our nice first test end. I don't like the weird casts in the Pong file, but that's a very minor and easy to fix thing. You know, we're gonna do one last thing right now because I feel like it. It's really surprising how slowly I actually ran those 10-minute miles. What did I? Honestly, my train pace is often slower than 10 minutes. I run slow. Where's the Oh, we don't have the graphic, do we? We need the puffer. I was gonna make the ball the puffer, but I think we'll wait on that. Yeah, Bet, you're just in time for... We got the thing to train somewhat, at least initially. So we have it mostly fixed. It needs a hyperparam sweep. Everything's good and clean. And I'm gonna take like 20 minutes to do a couple things. Default vecenv, native. Native, yeah. It's literally just pufferlib environment. This is it. But why what? Oh, we did. Yeah. But like, what I'm saying is, Puffer Env is the native format now. So you cut a layer. You don't need a wrapper called native. It is just native. Yeah. So this is the whole thing. It's not bad. There are a couple things to fix with it, but it's generally pretty nice. And the Pong M trains as well. All right, what I'm gonna do now is I'm gonna go take probably 20 minutes to do a couple things, and then I'm going to jump onto the Discord voice and help out with Go and any other environments that need an eye on. So for folks watching, that's on discord.gg/puffer if you want to hop in and check that out. And otherwise, you can support my work for free by starring the Puffer. Helps me out a ton. Other than that, good progress today. Short hours, but good progress on Vec. That was like a tricky bit of